We're going to continue with 2018 release test. We're on 32. What are the equation and slope of the line shown in the grid below? So remember the idea was, if you have the x, y coordinate grid and you have a line going only on or only touching one axis, which is the situation, the x-axis, then the equation is x is equal to whatever number this is. X equals a 6, x equals a 6. Okay, so the other ones, y equals a 6, are out. Now you got to come out here and measure slope, positive, negative, undefined, 0 slope. This one's undefined, right? So the slope is not 0, undefined. Cool? Or Mr. Slopey right here. So you got to remember that guy. He's going to help you out. He will help you out several times through this thing. Okay, so let's look at this one real quick. In the year 1900, the total number of metric tons of copper produced in the world was 495,000. Each year since 1900, the total number of metric tons of copper produced has increased on an average of 3.25 or 3.25%. I'm going to go back. Increase. So you want to see that it increases, okay? That is an increase. Check. That's a decrease. That one, these, we've never seen these right here, guys. There it is. Okay, it starts off here, and every year goes up right there. There's at 3.25%. That is a 1 and 3.25%. What do you mean, sir? Well, remember back in, I'm going to say 6th grade. Move it over twice. See it, 0.0325. There it is. What is the solution? Very easy, in my opinion. Just kind of use it, see one variable, and then the equal sign. My bad. I mean, and solve it, guys. That's what I mean. And solve this thing. Menu 3.1, 34x plus 95 equals 3 times the quantity of 14x plus 9 comma x 8.5. I haven't even read the question. That's probably going to be your answer. Oh, no. Okay, let's see what here. The graphs of the linear functions f and g are shown on the grid. F, guys, is the parent function. You can see it just goes through the corners. That's the parent function right here. Right here. And that's going to be y is equal to x, or f of x equals to x. Okay? So regarding this one right here, f of x is equal to x, your slope is 1. You see how this one's flatter? Like flatter, right? G of x is equal to a slope, right? That's less than 1. Because what's happening here, if you you can even figure out the slope. Rise of 1, rise of 1, run of 3. 1/3 x. Oh yeah, and that's it right there. Boom. Okay, there again, the reason that is basically x. So the same basically g of x is equal to 1/3 x, which is fx. Let me go back one more time on that one, just re-say it again. So f of x right here, I know as a parent function, and that's f of x is equal to x. So if I see this one, it's basically saying x. I know the slope is 1 here. This g of x has a slope less than 1. Now, I like to think about slopes, guys, like they're coming down the ski slopes. If I were to come down the ski slope on this one, I'd come pretty fast. Here, I would just come down slower. So my speed would be slower, / my slope is slower / lower. So that one's right there, a good slope. Now, I can actually figure out my slope by calculating my m to my rise over my run. And my rise from here to here. Why did I go up here to here? Because I saw that it's a good, a crossing right there. Good point. So a rise of 1, a run of 3. You got it? So then on g of x is going to be really 1/3 of x. But not really x, because they're saying, well, x is really f of x, so they're putting it as f of x. Just a real good reading kind of question there. Okay, which is equivalent? I can't tell you what to do on this one. You want to be crazy, you could say this is f of x, and you can graph this one. You can say this is like another f of x, like on your calculator, and graph that one, and see if they're all the same. I don't know. I think I'm just going to multiply them out. See, when I multiply this times this, I would get a negative 4h to the third. So that one's out, and that one's out. Now, all I got to check about is the last thing. Look at that. When I multiply the last things, negative 1 times a 3 gives me a negative 3. That's it. This saves yourself some time, you know. Kind of use the tricks I taught you guys. Every time the first thing and the last thing will kind of always stay with you. Okay, there are 15 plates in the kitchen cabinet. The diameter of each plate is either 7 inches or 12 inches. So x, y, the diameter of all plates, of all 15 plates combined is 140 inches. Okay, so x and y, x are 7-inch plates and y are 12-inch plates. So how many plates are there in all? Right there, right? So when I have x plus y, those plates, the number of x plates and the number of y plates, how many plates do I have in all? 15. Now, since they're talking about inches, I use the inches. 7x inches plus 12y inches equals 140 inches. Cool? Let me kind of reverse it. Okay, the graph on the grid, which best represents the domain. Oh, okay, so I need to see the top. Now, this one, the domain, is basically anything of your x values, right? So let's go down here. Anything with the y's is out. So that one's out. Now, domain basically says the x values, and then we're going to go from the least to the greatest. How far left does it go? Actually, it goes up, but it has a slant to it. So it really goes slanting forever in that direction. And the same thing for, that's just all real numbers. That means it goes up in both directions forever and ever. Just in case you like this first one, it says only from here to here. That's true on this grid because that's all you can see. But the arrows means that it goes on forever. Down. Okay, what is the equation of the slope and form of the line that passes through this point and perpendicular to this one? To be perpendicular, the slope, if it's going to be A over B, to be perpendicular, it's going to be B over A. This one's positive, this one's now negative. If this one's negative, this one's now positive. Okay? So we're going to go with the opposite of the reciprocal. Now, the slope here is 2 over 5. For it to be perpendicular, we're going to go with 5 over 2, negative. Out, out, and now it's either one of these two. Now, they want the point of 2, negative 2, right? So what I'm going to do is I'm going to graph this. Actually, I don't even care about this anymore. I'm going to graph these two and see which one goes through that point. Or you can plug the numbers in there. You got it? Or you can plug the numbers in there and then see what happens. I'm not going to do much. No thinking on my half. If I don't have to think, I'm just going to go out here and use this. 2, negative 2, 2, negative 2, as it goes to this point right here now. Oh yeah, 2, negative 2, perfect. If you want to see it better, you can go here to view and then grid, and there it is. 1, 2 over 2, and it's going to that point. You want to see that it's perpendicular to it also, you can graph the other one. You can graph the original one. Right? I'll just do that so y'all won't freak out. Perpendicular, you see how they're 90 degrees? All right. Which graph best represents? No. Oh, that doesn't help me at all. They're all, what? Look at this. They're all going up. So I was looking for one that goes down, decay. None of them do that. It goes through the y-intercept of 2. Ooh, that one's out. That one's out. It's either these two, right? Because like, that looks like pretty close to 2, and that one looks like pretty close to 2. Let's just see if this point or that point works. So what I'm going to do is I'm just going to graph it. Well, I'm showing how they graph it. Okay, do you see how this one goes to 1, 5, 1, and then 5? And then this one goes to 1, 10. So I'm just going to go Control T. 1, 10. See that? That's the one I want. Okay? This one goes to 1, 5. That one's 1, 10. So I like that. I graphed it and I put Control T. If you don't want to Control T, then you can actually go let me Control T and get rid of it. You can go to menu 5.1. I think y'all like to graph trace, right? And press to the right. Ooh, I can actually just type in 1. It shows me 110. Pretty cool either way. Sweetness. Just do uno más. Okay, so the area of a rectangular trampoline is that much. Area of a trampoline, so that means length times width is equal to this. The length of the trampoline is 6 feet greater than the width. What's situation represented by this one right here? What is the width of the trampoline in feet? Ooh. Okay. It's saying a whole bunch of good stuff here. Can you just find a number that works here? Hold on real quick. Okay, sorry guys. So I'm looking at this one. What I'm seeing is these two things, when they multiply them, give you that. Slash, that's what this is. There is the multiplication. So in my opinion, I would just graph it, you know? Graph it and find the width and the things. Hold on, guys. Okay, so just graph it, like I said. Go to a new document, graphs, and then just plug in there. Instead of w's, we'll put x's, okay? X squared plus 6x minus 1, 1, 2. Okay, whatever that number is, it has to be that one. 1, 2, 3, 4, 5, 6, 7, 8. It's that simple. They give a lot of words. Just graph it. No, I'm telling you this much. You see this thing? It comes like this, and then it comes like that. I guarantee it. You can just look at the thing. But length can only be positive. So there's no way they can give you that -1. Okay? So when you zoom, there you see there's a -1. So it comes down like this, and it comes back up. That's going to be the 8 one that we had. We don't need that -1 because there's no length or width of anything that are negative. Okay, we'll do this last one for right now. The table shows a linear relationship between the linear, I see this linear, I'm already thinking rate of change, there it is, that's all I did. Look how I read it, real quick, rate of change, linear, just use these things right here. This is spreadsheets menu 413, guys, that's it. That's actually easy. By 1, it changes 7. Menu 4, 1, 3. B, control this. Rate of change is 7. Okay, I do want to comment. Remember, the rate of change, guys, is also known as your slope. Okay, your slope is going to be y2 minus y1 over x2 minus x1. So if you look at this real quick, this one minus this one is 7. This one minus this one, what? 1? And that's what this is, subtracting, subtracting. All right, now in this situation, it's 7 over 1. 7. That's how I did it. And this is how you can do it too. This changed once. How much does it change here? 7. And that's it. Really simple, really easy. We're going to stop there.